So I've died of coughing. Um, I've seen some videos online lately about imaginary numbers. I'm not sure if I'm just seeing them all at once because that's what my YouTube is doing. Or that's what YouTube thinks that I want to see right now, or I don't know what's going on. But I've seen a lot of these guys lately, and none of them touch on, in my opinion, the simplest way to think about imaginary numbers. Right? So, say we've got, let's just build up our number system real quick. Say there's 0, right? Here's 1, here's 2, 3, yada yada. That's going to go out to infinity, right? So there's 1, 2, 3, nothing. Right? So there's our positive numbers, including 0. Over here, not a problem taking square roots of stuff. It just ends up being some number closer to 1. But we can go into debt too. So say like we're considering this to be money or something. So if I had $3, that would definitely be better than being in debt $3, right? So we have negatives, or you can consider this forward direction and backwards direction, something like that, right? Whatever works. There's a lot of contexts that this will work in. That's fine. So we end up with, there you go. There's our origin is right there. So we have our positive numbers and our negative numbers. We can take square roots of these guys. When we try to take a square root of these guys, it's not one of these numbers. So it must be over here somewhere. It doesn't lie on this line, so it's got to be somewhere else. Right? We have lots of room to work with, so we can put it anywhere off the line. That's fine. So let's say this is the square root of -1. Okay, well, if we take that and we multiply it by 0, what happens? We get 0. So we end up with a line, and we can certainly scale it up, right? So like 2 square roots of -1 would be up here, and this would be an infinite number of square roots of -1. And same logic applies, right? We can go in the negative direction. Right, so this is the negative square root of -1, and this will be -2 square roots of -1, and out here we get negative infinite square roots of -1. Just look at that. I didn't even do anything other than say, well, we have this number line. When we take the square root of a negative number, it was not on the number line, so sure, say it's up here. And then what ends up happening is this is just perpendicular to this, regardless of the way that I drew it. Just that's it. That's how that's worked. That's it. That's all there is to it. And no component of this is along the number line, otherwise we would have found something. When we take the square root of -3, for instance, we would have gotten something. Something would have shown up as a number here on this line, but nothing showed up. So it's completely perpendicular. This is a lot like the division by 0 problem, right? Where division by 0 doesn't yield an answer because it indicates that we're operating in a perpendicular dimension to the one which we actually have the authority to operate in. So we can't know anything about what's going on there. It's just invisible to us. And that's what happens. That's why the square root of -1 is invisible to these numbers, because it doesn't live on this line. It lives out here. And then once we've established that it lives out there, well, we can automatically set up its own number line, which is perpendicular to our original number line. And then you can get quaternions quite easily, or any number of these things, because what we've done, so say we're looking at it like, we're looking at it this way. Alright, that's an eyeball, and we're looking at it this way. So we're looking down the number line axis. So that's the number line right there. So say this square root of -1 axis is like this, going off this way and this way. Well, we can go perpendicular to that just fine. Alright. And if we had a higher number of dimensions, we could go perpendicular to that, and perpendicular to that, and they'll all be perpendicular to all of the other ones, right? So both of these create a plane that's perpendicular to this. And every possible line I could draw on that plane that goes through the origin is effectively the same as this. It's indistinguishable from this, really. So when we're looking at quaternions, the reason that they all end up being like I, j, and k, all three of the other dimensions end up operating very much relative to your regular number line, operating very much like the imaginary numbers, is because they effectively are. They're all the same thing, really. They're all perpendicular to this. But they're also perpendicular to each other, so they have some special relationships to each other. But none of those relationships between each other is visible from this dimension, from the original number line. And that's pretty easy to just set up and see. And I'm kind of confused why nobody's presenting anything in this sort of direction, because I feel like you can get a lot of intuition off of this just very, very quickly. It doesn't give you everything, This doesn't necessarily explain to you things like why, like, let me see, make sure I remember this correctly. E to the pi I equals -1. It doesn't necessarily explain this thing intuitively, but it gives you a lot of the other properties of imaginary numbers pretty quickly, pretty easily, and it explains, well, we couldn't find it here. It's not one of these numbers, so let's just we're drawing this number line on a sheet of paper. There's a lot of paper left. Let's just put it out here. See what happens. What are the consequences of putting it out there? Oh, the consequences of putting it out there are that we get the imaginary numbers exactly correctly, because that's how it really works.